Hello, I am Jayanta from Department of Metallurgical and Materials Engineering, IIT Kharagpur. I am working here as Associate Professor. This year, I am running a course on Advanced Materials and Process in NPTEL. The advanced materials are often called, but all time the questions come to our mind, what are they? Since 2001 onwards, I am doing research on several aspects of material, mostly on advanced materials. So, these advanced materials could be mostly or broadly categorized into structural materials or let us say the functional materials. Usually, engineers select a material for application or function based on some properties, and these properties are very much important, mostly mechanical, thermal, corrosion or environmental, or some other functional properties like electronic properties, optical properties and so on. But these days, besides all the different application, we need more and more smarter materials. A smart materials, as an example, like shape memory alloys, okay? And I can show you one example of such smart materials. Let us do an experiment. I have taken a paper clip and kept it in the ice water solution. You can see the temperature of the ice water solution is very close to 0 degree centigrade. Therefore, the temperature of this paper clip is also near 0 degree centigrade. Let us try to deform this material. So, you can see that I have deformed the paper clip, means plastically deformed the paper clip, and slowly I keep it in a normal water. The temperature of the normal water is 28 degree centigrade. So, now let us take this paper clip once again and warm a little bit. So, I get back the original shape as it was, and this is really smart material. Actually, it is a nitinol nickel titanium alloy. So, among advanced material, the structural materials are also being developed day by day. So, there are a couple of examples I can tell you, like advanced structural steels. So, usually the steels have a 200 megapascal strength. So, if we decrease the grain size to nanometer scale according to Hall-Page equation, we can simply, or even experimentally it has been proved several ways, that bulk steels could be produced at a strength of 2 gigapascal. So, this is fascinating. Actually 10 times higher strength we can achieve in a steel by manipulating the microstructure. So, this is one class of advanced material. Also, we all know about several lightweight alloys. Lightweight alloys not only important because of its low density, but the strength to density ratio or strength to weight ratio. So, if you look at any of the Ashby plots, and then you will find that how important these lightweight alloys such as aluminum alloys and titanium alloys, magnesium alloys are. So, we definitely need a general awareness of these materials and what is the demand today in engineering's world. If one has to design a wing of an aircraft, then definitely a high E modulus or Young's modulus material is required, and definitely we should go for some composite or aluminum based composites which will have low weight, as well as we should have high Young's modulus. On the other hand, high temperature alloys are also important, because if we have to develop a turbine engine, then the material should survive at a temperature much higher than 1000 degree centigrade, whereas titanium alloys cannot survive at such a high temperature, and therefore nickel based superalloys was developed or being developed day by day, not only in terms of manipulating their microstructure, but also in terms of processing condition, so that the material can survive at much and much higher temperature. I can show you some of the example of such nickel based superalloys. So, as I said that the superalloys are being developed and they are regularly used for gas turbine, or let us say for any kind of aircraft turbine, or let us say generating power, and there we need material for higher temperature, because the higher the temperature, the efficiency of the Carnot cycle will increase, and the net power or the efficiency will also increase, and therefore such material should survive. And you can see how precise the blades are made in a gas turbine engine, and these are single crystal prepared by injection molding technique. You can clearly see the intricate shape of it, where two of such blades are kept. Now, if we come to another emerging material like bulk metallic glasses, here you see how the aesthetic nature, this is a directly cast alloy of a zirconium, copper, nickel, aluminum. The strength of this alloy is above 2 gigapascal, where conventional zirconium alloys fails. It has very high resilience. We can use as a pressure sensor, we can use as a tennis racket handle, or maybe we can use as a golf club, so that we can knock a ball to a very long distance. So, materials could be exploited, and these are well known mechanical properties. Among lot of other functional materials we will discuss in detail. So, please join, and this is a general awareness required among all the engineering science discipline for developing advanced materials for future generation. Thank you.